recording. Okay, so today we're going to start chapter 2. Chapter 2 covers both rational and polynomial functions. We're going to start with polynomials. Polynomials are anything of a higher degree. We're going to first look at quadratics and move on from there. The rationals will get a little trickier, but we'll cross that bridge when we get there. So we got a few different types of basic functions. We have a constant function that is f of x is equal to a. That is just a horizontal line. Then we also have a linear function. Remember, y equals mx plus b. That was a large focus of chapter 1. So again, that shouldn't be too different or challenging of a definition there, as we've been seeing linear functions for quite some time. Quadratic function has x squared as its highest power. Two things we're going to talk about with quadratics today are the axis of symmetry, which is the line where the parabola is symmetric to itself vertically. And that can always be found by using x is equal to negative b over 2a. And then the vertex will be the max or the min. The vertex happens at your axis of symmetry, comma, the y value associated with it. So the point negative b over 2a, comma, f of negative b over 2a. So that's just saying, hey, once you get your axis of symmetry, plug that point in, and that will give you your x, y vertex. So save that. Okay, so that's our basic vocabulary. So here with this, let n be any non-negative integer, and let a sub n minus 1, all the way down to a sub 1 be real numbers with a sub n not equal to 0. A polynomial function of any degree is a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, all the way down to just like an x squared term, an x term, and then a constant term. So that's just a really fancy definition for the idea of a polynomial. But you guys have seen polynomial sum. It's just any higher power function. So quadratic function is a polynomial of second degree. The graph of a quadratic function is that U-shaped curve that we call a parabola. Again, I know we've talked about this in previous classes, and you've seen this in previous classes, so this shouldn't be feeling too foreign or different or like completely new. It should feel kind of familiar. Okay, let's take a look. So the leading coefficient, sorry, just got a few people coming in. Thank you guys for being here, everyone. I'm getting those attendance fixed. And there we go. The leading coefficient of a quadratic function is positive. That means it opens upwards. If it opens upwards, it has a minimum. If it is negative, it is a downward facing U shape. Therefore, it will have a maximal. So again, a positive a value in front tells me it opens up. Negative a value tells me it opens down. Positive a value means it has a minimum. And a negative a value tells me it has a maximal. Okay, so what we're going to do now is talk about vertex form. Vertex form looks like this, where H and K are the vertex, hence the name vertex form. If you notice, this vertex form looks awfully a lot like how we shifted our functions in chapter 1. That's because that is what we're doing. When we were shifting our quadratic functions, we were specifically moving the vertex of it. So vertex form gives us the vertex will be H comma K, and that axis of symmetry is always going to be H. So again, kind of relating that back to what we did in chapter 1. So if we are trying to write a function in vertex form, we're going to need to find the vertex using negative b over 2a. And then if we need to find the x-intercepts, we're either going to need to use the quadratic, this should say quadratic formula. Or factor the quadratic. So in our do nows, we're going to have that practice with factoring where we do those like two sets of parentheses, be like, oh, that factors x plus 2 times x plus 3 or whatever the case is. So let's take a look here. This is what we're trying to do. We're trying to draw accurate graphs. With these, I know I'm being pretty like, oh, just use Desmos to graph. I would like hand-sketched graphs for these. So you're showing me you understand our important aspects of it. Now, you can get a lot of this information from Desmos too. I am first going to do this, getting all of my information just from the problem. I'm not going to use Desmos at all for it. Then after I do it that way, I'm going to show you how Desmos can pull all the same information for us. So, I'm going to start with the vertex and axis of symmetry. So for the axis of symmetry, that is negative b over 2a. So my b value is 2, so that's going to be negative 2 over 2, and there's nothing in front of x squared, so that's 1. So that's going to be negative 2 over 2, which is negative 1. So at x equals negative 1, I'm just going to draw a vertical dashed line. That dashed line represents my axis of symmetry. Any questions so far? Okay. Now what we're going to do is move on to the vertex. For the vertex, we're going to plug in x equals negative 1. So f of negative 1 here will be negative 1 squared plus 2 times negative 1 minus 8. Let's see, that's going to be 1 minus 2 minus 8, which should be negative 9. So, that is going to require a lot more space than we have here. So that's 1, 2, 3, 4, 5. Let's extend this down. 6, 7, 8, 9. That looks close enough to evenly space. So my vertex is negative 1, comma negative 9. and that will be this point right here. Let's send that axis of symmetry. Okay, now finally I need to find my x-intercept. So I'm going to use the snowflake method to solve and factor this, or factor and solve this. Sorry, got the order backwards there. So here with this, x-intercepts. So let's start with this. It's a -8 up top, 2 on the bottom, 1 and 1 on the sides. So when I think about -8 or 8, that could be 1 times 8 or 4 times 2. Now, if I do 4 minus 2, that will give me a +2 here. -2 times 4 is -8. So my magic numbers are 4 and -2. So that's going to be x plus 4, x minus 2 is equal to 0. Because when I'm at my x-intercept, my y value is 0. We can split and solve these. X plus 4 equals 0. X minus 2 equals 0. Subtract 4. X equals -4. Add 2. X is equal to +2. So I'm going to place those on here. So +2 and -1, 2, 3, 4. And then all I have to do is draw a symmetric U shape like so. So this is how we handle this mathematically. These are skills you've covered over the last few years. I know the axis of symmetry is kind of a new one. I know that's not fully covered in IM3 or IM2, but finding your x-intercept, that idea of factor, you're using the quadratic formula, I know was introduced in IM1, covered in IM2, and covered in IM3. So there we go with that. Let's take a look at Desmos quickly and see pulling the same information from there. So this was f of x is equal to x squared plus 2x minus 8. So here is my vertex. For those of you in the classroom, I might want to move that up a little bit. Oh, and changes to projector mode. There we go. There's my vertex, -1, 9. So that also means my axis of symmetry, if I wanted to put that into Desmos, would be x equals -1. Notice it is symmetrical about that. I can even change that to a dashed line to make it look more like what I had. And again, get that vertex there. But I also get my x-intercepts with it as well. Now remember with Desmos, if I want the vertex, just tap on the vertex, just click on it, and it tells you that. If you want the x-intercepts, go to the x-axis and just click where it is. It's that easy. I know if you saw how to do it on the TI Inspires or TI 83s or 84s, it's a little more involved to get your x-intercepts. It's a little more involved to get your vertex. Desmos, it's just as easy as clicking on them. So those are the same 3 critical points I used to graph my hand sketch of this. For your homework, please do not just send me this on Desmos. I do want to make sure you're able to pull that information and understand how it relates to graphing it by hand. So for any quadratic function in this form, if a is bigger than 0, it has a minimum that occurs at the point negative b over 2a. So that's again finding our axis of symmetry, then plugging it in. The only thing that changes in this line is now it's saying a is less than 0. Now all of a sudden it becomes a maximum at that point instead of a minimal. So again, summary of this is saying a lot in fancier mathematical terms, but to find the max or minimum, find the x value using negative b over 2a, then plug it into the function to find the y value. So again, I know this is saying a lot of fancy stuff mathematically. I'm trying to get you used to seeing that more proper mathematical writing there, but that's all it's saying. Find your vertex or find the x value, negative b over 2a, and plug that in. So find the minimum value of this function. At what value of x does the minimum occur? So we're just going to go through the math of it by hand. And again, we'll take a look at it on Desmos to confirm our work. But I do want you to know how to calculate this by hand, because it's A, not too hard of a task, and B, I don't want you fully just 100% relying on the calculator. So again, axis of symmetry, I can abbreviate that AOS. So that is x equals, again, negative b over 2a. So that's going to be negative 11 over 2 times 3. So that's 11 over 6. Oh, okay. We're going to have to deal with some fractions here. No big deal. So let's now go ahead and plug this in. F of 11 over 6 is equal to 3 times 11 over 6 squared minus 11 times 11 over 6 plus 16. Let's see. 11 squared is 121. So 3 times 121 over 36 minus 121 over 6 plus 16. Let's see, this can reduce to a 1 and a 12, and that can make my common denominator here 12. So I'm going to multiply this by 2 and 2, and then this is really 16 over 1 times 12 times 12. So that's going to be 21 over 12 plus, or no, not plus, minus 242 over 12. And let's see, 16 times 12 will be plus 192 over 12. So let's see, 121 minus 242 is negative 121 plus 192 is going to give me 71 over 12. That was a fair amount of work there. So our min is 11 over 6, comma 71 over 12. Any questions about how I did that before we confirm it using Desmos? I know there was a lot of work with fractions in there. You know, you could have grabbed a calculator at some point and just plugged it in using a calculator. Again, I could show us how we can do that on Desmos as well. Okay, let's take a look at Desmos as I'm not seeing the questions popping up on the chat. And we'll get the people in front of me. It looks like we're pretty good. Okay, so f of x is equal to 3x squared. No, not cubed, squared, minus 11x plus 16. So there we go. There's my parabola. If I click on this, I get in some weird looking fractions, right? Watch this. If I do 11 over 6, 1.83 repeating, hey, this decimal is the same as that fraction I just got. Let's see what 71 over 12 is. Hey, that's the same decimal. I got this decimal. It matches up with this. So hey, we did it right. We were able to do it without actually looking at the graph itself. We were able to say what the minimum was. And even if I do it this way, I could do f of 11 over 6. And if I want that as a fraction, I can use the little fraction here, 71 over 12. Same thing we got as calculating it by hand. So, you know, Desmos can be a very helpful tool here. But for this, I want you using it a little more as a tool versus the sole way you're graphing it. You should be able to do the math behind it. I know the piecewise functions, I said, hey, if you can figure it out on Desmos, that's good enough, because I know students have a lot of struggles with piecewise functions, and Desmos did involve a fair amount of work just to do it on there as well. But for quadratics, this is stuff that you can calculate by hand. So that takes us to the end of today's lesson. So on page 96, there's a new PDF up. So if you had downloaded and saved the chapter 1 PDF, that's great, good on you. But now we're on chapter 2, so there is a new PDF for that. So please make sure if you were downloading it and just constantly using that downloaded file, you download the next one. If you were just clicking on the one I post, you're fine. So we're going to do page 96, 1 through 4 all, 10 through 16 even, and 22 through 28 even. So please, I know we have about 10 minutes left. You could give that a try. I'm also open when this 4th market period and for seniors. I want to say it's around May 22nd for whatever reason. That date seeming to be very familiar in my head. However, I feel like I could be off by like maybe as much as a week or so. Again, I don't remember if it's the exact day, but I know it's around there. It might be a week later, but 22nd for whatever reason sticking out in my head. So if you have any questions about anything, just let me know. And I'm going to stop the share and stop recording. Thank you all for being here.